All right, here we go. So, page 76, chapter 3, computing with numbers, programming exercises. Number 7, write a program that accepts 2 points and determines the distance between them. So this is going to be distance.py and formula is going to be it's going to be this to the square root of that. So that's star 0.5. So it's going to be x2 minus x1 plus y2 minus y1 squared. And then take the square root of that. So that's going to be so we'll make sure we get all those right. I might be a little bit wrong on that, but as far as the parentheses, but so this program takes 2 inputs and calculates the distance between the points. Two points as inputs, x1, y1, x2, y2. Okay. All right. Let's save it. Distance.py. There we go. Okay, so let us see. So let's do x1, y1, x2, y2. Let's perform a function. Let's call this distance. And we'll make this the other way. I think the last program was the other way. So we're going to take x1, y1. So d equals. So the first thing we're going to do is we're going to do. I just want to make it real simple. So let's do x formula, then the y formula, and then d. Just so we don't mess up on any of the parentheses. So this is going to be x2, and plus it's easier to read, I think, x1, and then we're squaring this. Right, so x2 minus x1 squared, right? And this is going to be y2 minus y1 squared, right? So it's going to be x formula plus y formula, right? And then that's going to be 0.5 to the 1/2 power. That's distance. So we'll call that dist. So x1. So let's do int float. Let's do input. Actually, I think we can do this in one shot. Let's see if we can do this in one shot. We'll just comment these out. See if I can remember this without looking it up. So please enter x1, y1, x2, y2. I'm pretty sure we can do and then we'll just call it. We'll just call it as we'll just do distance, and then we'll take those arguments and we'll place them in the function call, and then make sure they correspond correctly. And now they're in those parameters. All right. So now let's try. Let's do print. I think if we print it, it should be okay. Okay. So now let's try it. Just play it in here. It's gonna be here. Okay. So I'm gonna open it. Distance.py. Okay. I think we're pretty good. I think so. Okay. So 2, 5, 7, -1. Oh. Cannot convert string to float. So, I guess it thinks they're all strings. All right. So I don't want to look it up because I want to keep the pace of this going strong. Plus, I want to quiz myself. And, also you want to go for what is a little bit simplest for you, because I'll get better as time goes on. Like, I'll just pick stuff up. And I'll just, and I guess I'm not ready yet, to handle that. So, float input, please enter x1. Please enter x2. Let's see how this comes off. This is not going to be x2, it's going to be y1. y2. Okay, let's run it. I was going to save that in Atom. Let's run it. 3, 8, -9, 0. Oh, none. Okay. Why did we get none? Well, with no return, the default is none. So we're going to return the distance. That's what we need to do, is return it. Okay. So, here we go. Open. Distance. All right. I think it's pretty good now. We got the return distance. Print that out. All right, here we go. Let's run it. Okay. So let's do it real quick. So y1, y1, well, x2 minus x1. Let's just do x2 minus x1. So let's just walk through it. So it's negative 4. So it gets rid of all the negatives, right? So negative 4 squared is 16. Then y2 minus y1 is going to be negative 11 minus 9, which makes it more negative. It's negative 20. It's 400. 400 plus 16 is 416. Right? So the square root of 416 is going to be right around 20, a little bit above 20, because the square root of 400 is 20. And so it's just going to be barely above that. Yeah, so the other thing we can do is 20.396 times 20.396. You know, we can do this. Yeah, look at that. Times 416, there it is. That's what we got. So we would obviously test this like, 10, 12 times. Put a bunch of test cases in there. And I check out. But it looks good to me, and hopefully this was helpful. All right, thanks.